Hey there, this is Mr. Alexander, and today I'm here to talk to you about multiple representations of polynomials. And the main idea here is there's basically two kinds of polynomials. Ones with even leading exponents and ones with odds. The ones that are even bounce off of the x-axis, and the ones with odd will wiggle through the x-axis. Also, x squared, x to the fourth, x to the 10th, they all have one solution at x equals 0. Every time that it touches the x-axis, that's a solution. So all three of these functions have three solutions, but they all have more than one zero. X squared has two zeros. X to the fourth has 4 zeros. X to the 10th has 10 zeros. Even though it only touches the x-axis once, it has multiplicity around this point of 2, 4, and 10 respectively. Same thing over here. Even though x to the third only touches x equals 0 one time, that means it has one solution but 3 zeros. X to the fifth has one solution but 5 zeros. X to the 11th has one solution and 11 zeros. Now, if there are added parts to this function, it could potentially have up to 2 solutions. This one could potentially have 4 solutions. This one could potentially have 10. Once you start adding in terms here, it could modify the graph in such a way that it crosses the x-axis more than once, up to 10 times, up to 3 times, up to 5 times, up to 11 times. So if I turn the page here, and I look at a function like this one, 3x to the 8th plus 4.2x to the 7th, minus 6.1x squared minus 10x plus 5. The degree of that function is always the highest exponent. So the degree is 8, which means it could possibly cross the x-axis 8 times. I don't know if it does or not. I just know that it potentially could. But I know exactly how many zeros it has, because it's always equal to the degree, which is 8. Now, since it's a degree of 8, that's an even function. Or sorry, the exponent is even. And so going back over here, x to the 8th would be somewhere between x to the 4th and x to the 10th. I know that's going up forever in both directions. So the end behavior as x approaches negative infinity, I know it's going to go up and to the left. And as x approaches positive infinity, I know it's going to go up and to the right. Let's look at another one of these. So 2.7x to the 11th plus 2.2x minus 3.8x to the 4th minus 1.7x to the 3rd plus 9x. The degree is the highest exponent, which is 11. The number of possible solutions is also 11. The number of zeros, 11. And the end behavior. So now this one's odd, which means it's going to look something like this one right here, this x to the 11th. So as it goes to negative infinity, I know it's going to go down forever. And as it goes to positive infinity, I know it's going up forever. So the end behavior looks something like this. Let's do 2 more of these. So this one, the leading term, the degree is 7, which means it has 7 possible solutions and exactly 7 zeros. 7 is odd, which is the same as this guy. But since now this function has a negative in front of the leading exponent, it's going to have the exact opposite behavior. So instead of going down this way and up this way, the negative's going to make it flip, so it's going to go up to the left and down to the right. The negative in the front switches the behavior. So that means that it goes up and to the left and down to the right. Last one that we'll talk about. It looks like the 6 is the degree, which means it has 6 possible solutions and 6 zeros. Now it's even, so normally that means it goes up to the left and to the right. It's got that bouncy action. But since there's a negative in the front, it's actually going to go down to the left and down to the right. Now we've done all of that, so we could make this slightly more complicated. First off, when it's to the power of 1, it's simply going to cross. When it's the power of 2, 4, 6, 8, and so on, it's going to bounce. When it's the power of 3, 5, 7, 9, 11, and so on, it's going to wiggle. So I'm looking at this function right here. X plus 3 squared times 2x plus 1 times x minus 2. If I was to set this x plus 3 squared equal to 0 and solve, I would end up with x equals negative 3. But it's squared, which means the multiplicity is 2. And when the multiplicity is 2, it's going to bounce on x equals negative 3. 2x plus 1, if I was to set that equal to 0, this factor, I'd end up with, let's see, I subtract 1 divided by 2, that's x equals negative 1/2. And the exponent on that is 1, so the multiplicity is 1, which means it's going to cross at x equals negative 1/2. The last one, x minus 2 to the first power. Set that equal to 0, and you've got x equals 2 with a multiplicity of 1, which means it's going to cross. Now, to get the leading term, all you need to do is add these up. 2 plus 1 plus 1 is 4. That means the leading term is x to the 4th. And x to the 4th, we know, goes up and to the left forever and up and to the right forever. So I'm going to try and draw a rough sketch of this thing. So I've got my negative 3 on the x-axis, I've got my negative 1/2 on the x-axis, and I've got my 2 on the x-axis. Well, I know my end behavior. My end behavior has to go that way and that way. The question is, what happens in between? Well, at negative 3, it's going to bounce. So I'm just going to bring this thing back up. At negative 1/2, it's going to cross. So I'm going to bring this thing down and let it cross. And at 2, it's also going to cross. So I'm just going to bring that on in there. And that's a rough sketch of what that thing would look like. That's what this function looks like without having to use any calculator. Let's look at the next one. Here we've got negative x plus 3 times x plus 1 squared times x plus 1 cubed times x minus 2 squared. So if I take that x plus 3 and I set it equal to 0, I'm going to end up with x equals negative 3. And the multiplicity on that, we've got an exponent of 1, so the multiplicity is just 1, which means it's going to cross. Set x plus 1 equal to 0, and you've got x equals negative 1, but it's cubed, so that means the multiplicity is 3, and this thing's going to wiggle. We've also got x minus 2 squared. Set that equal to 0, and you've got x equals 2 with a multiplicity of 2 because the exponent is 2, which means it's going to bounce. Well, if I add up the multiplicities here, 1 plus 3 plus 2 is 6, which means my leading term is going to be x to the 6th, but in the original, there's a negative right there. So that means that the leading term is negative x to the 6th. So instead of this thing going up to the left and up to the right, it's going to flip down backwards. It's going to go down to the left and down to the right. That's the effect of taking x to the 6th, x to the 4th, x to the 10th, and putting a negative in front of the leading term. It flips it over the x-axis. So it's going down now. Alright, so we've got enough information here that we can draw a rough sketch, which I'm going to do now. So if I put line at x equals negative 3, x equals negative 1, and then x equals 2, I always like to start with the end behavior. I know it's going down to the left and down to the right. And now we try and figure out what's going on in between. At x equals -3, it's just crossing, so I'm going to go ahead and let it cross. At x equals -1, it's going to wiggle. Now remember, the wiggle kind of looks like this, so that's a little tough to draw, but you can kind of get a rough sense of what it should do. It should kind of wiggle just like that. It's not a straight line, but it's also not too curved. And at x equals 2, it's going to bounce, so I'm going to bring this thing back up and let it bounce off of 2. And that's what that sketch looks like, right there. So it doesn't have to be perfect. We're just trying to make rough sketches. How do we graph these polynomials without having a calculator? Let's do one more. Let's look at, I'm looking at this one right here. 2x to the third times x minus 1 times x minus 2 squared. Well, if you set 2x to the third equal to 0, you would have x equals 0 with a multiplicity of 3, which means it's going to wiggle. Set x minus 1 equal to 0, and you're going to have x equals 1, the multiplicity of 1, and that means it's going to cross. Finally, you got x minus 2 squared equals 0. You're going to end up with x equals 2, the multiplicity of 2, which means it's going to bounce. Okay? So if we add up those multiplicities, we're going to have 3, 1, and 2. That's 6. So this thing's going to be x to the 6th, which means it's going up forever and up and to the right forever. We're ready to try and draw this thing now. So we get our x-axis. We put x equals 0. We put x equals 1 and x equals 2. And I know that it's going up to the left and up to the right. At 0, it's going to wiggle. So I'm going to try and make that thing wiggle a little bit as best as I can. Make it cross at 1, and I'm going to make it bounce at 2. And that's how you make these rough sketches. Nobody's expecting you to be a perfect artist, but they're expecting you to be in the right neighborhood, right ballpark. Okay, just one other thing I want to talk about is some of these comprehension questions. So, like this one right here. This is a good one to talk about. Determine which function j of x or k of x has the greater output as x approaches infinity. Explain your reasoning. So you've got j of x, which is a quartic with a negative leading term. We've also got a quintic, which means x to the 5th power, where a is greater than 0. Well, that a is the number in front of the x to the 5th, so it's like 2, 3, 4, 5, or something. We know it's positive. It's not negative. So if I was trying to draw j of x, I know that a 4th degree polynomial that's negative in front is probably going to look something like this. And k of x, if it's quintic, that's going to be, and it's positive, that means it's probably going to look something like this, probably. What's happening in between is not actually important. The end behavior is all we need to know to answer this question, because it says which one has the greater output as x approaches infinity. So as you move to the right, which one ends up with a higher value? Well, that must be k of x, because this one ends up at negative infinity, and this one ends up at positive infinity. So what we've done in this video, and what we did in class, was we simply tried to look at portions of a function. When we're given some information about a function, we don't know everything about it, but we know some things about a function. Can we figure out some other characteristics using logic, so without a calculator? So the whole idea here was to try and use your logic and your brain to try and answer questions about polynomials. So thank you for watching. We'll see you in class.